Hope you have a lovely lunch. Our talk today is Building Platform for Data Scientists, and we have Rick Walker to talk through that. So a little bit of bio about Rick. So Rick is a data scientist that joined King from a wide range of background. And as the team size grow, it makes sense to provide great tools and platform for them to work on. In this talk, Rick will discuss what these tasks are and how to build a platform that data scientists love to use. So please welcome Rick.
So, hi everyone, and thanks for coming to my talk. I know I'm scheduled against some great sessions, so I really appreciate it, and I hope you enjoy listening today. Before we kick off properly, just some housekeeping stuff. First, can everyone hear me okay? Yeah, fantastic. I would say I'm not used to using a mic, but that's mostly a lie these days because, like many of us, I guess my work environment for the last year has looked like this. And it's a relief to have an actual AV guy here because I've spent a lot of time on Zoom being, can you hear me, can you hear me, can you hear me, for about 18 months now. So this is a really nice change. So next bit of housekeeping, questions. It would be great if you could hold questions until the end. I've timed this presentation, I've run it a couple of times myself. It's around about 30 minutes. So there'll definitely be time at the end. And I'm happy to answer more questions afterwards. I'm around all day. If you have questions about the company more generally, please swing by the stand. I'd like to keep this session focused on questions about this topic. Finally, I'm going to need some minor audience participation in this talk. It's not a lot, but it would really help me out. In particular, there'll be a couple of times I'll ask you to raise your hand if something is true for you specifically. Let's try that out. If you would say your primary language for data science is Python, could you raise your hand now, please? OK, thank you. How about if your primary language is R? OK, I mean, that's interesting. How about if it's something else? Oh, we might talk afterwards. I'm interested now. So that's kind of interesting, actually. We survey this at King occasionally. We have about 100 data scientists at King. And last time we did this, it was something like a 57-43 split in favor of Python. So we're not quite the same balance here. The flip side is, of course, if you're an R user, there's a reasonable chance that you also use Python at some point for certain things. And I suspect the converse is less true. But anyway, today I'm going to be talking about data science platforms from my perspective at King, where I work on a team dedicated to making the work of data scientists easier and more efficient. When I was writing this talk, I thought it'd be a super technical one, but actually it really hasn't turned out that way. I'm talking about systems we've built at King, certainly, but that's not the focus of this talk. What I'm hoping is that you'll come away from the session with an understanding of some of the things you might want to consider if you're looking at data science platforms. A quick intro to me. Hi, I'm Rick. These days I'm a data scientist at King, but previously I was a research academic. And I worked across maths, computer science, astrophysics, statistics, data mining, data visualization across undergrad, PhD, postdoc work. But if I had to pick one traditional field of study that defines my background, I would say that I am a computer scientist. At this point, I'd like to do a small survey. Could I get a show of hands for each of these? How many of you would say that your primary field of study of our academic study is computer science? OK, thank you. How many would you say it's economics? Ooh, that's interesting. Maths or stats? What's next on my list? Physics. Data science. OK. Machine learning. OK. So this is pretty interesting to me. And since you've given me some data, I thought that I would reciprocate by giving you some data back. We've collated this stuff at King for a long time. This is looking at highest academic degree of people who are currently data scientists at King. And this is roughly the split. These are the top 7 backgrounds for data science currently at King. This was surprisingly awkward to put together, because if someone's degree is in biophysics, what do I count that as? And you know, this is a classic data science problem. How do you count things depends on how you categorize them. It's a bit different to what we've just seen in this room. But the one I want to focus on is this bit. And my point here is that computer science is a really uncommon background these days for data scientists. And I'd like to be clear on this. It's not that I think a computer science degree is the best background in any way. In fact, I don't think any one degree is the best background for a data scientist. Depending on what you've studied, you'll have different skills. And the goal of a data scientist is to use the skills you have to help drive business value. So having, you know, in your company, having data science from a range of backgrounds is great. But what I'm going to use studied computer science as today is a proxy metric for has experience preparing and maintaining their own computational environment. If you're a computer science student, you've had to write code. You have to maintain a development environment for that code. You have to maintain libraries, dependencies, and so on. Like all proxy metrics, this has some holes. Of course, there are people who do economics, but also know how to do that. But I think this is a useful lens for looking at the rest of this talk. So this is something I'd like you to bear in mind. Most data scientists are not computer scientists. What are the implications of that? Well, let's look at what data scientists at King do. On a technical level, it mostly comes down to these 4 things. Data scientists at King need to do analysis, to schedule jobs, to build and deploy dashboards, and maybe do some machine learning things that I'm not going to talk about today because MLOps is a whole different topic. Although if you want to talk about that, I'm happy to chat about it later at the stand. What do I mean by each of these? These days, we, and I assume most of you, probably reach for notebooks or perhaps R Markdown documents when you're doing your work. Every time I do analysis, what I really mean is pull up a notebook and write some code to do something. And notebooks are a very nice computational environment to use. But you do still need to set it up and run it somewhere. At King, we actually operate on a no report without code basis. So every report is backed by the code that was used to do the analysis. Everyone's notebook's going to a Git repo. And then we can do things like code review within or between teams. To be able to review your code, someone else needs to be able to run it. And that means they need to be able to replicate your environment. And that can be complicated. You need the same combination of language and package versions, and maybe even the same credentials or authorization to access the same data sources. And if you can't do that, you can't replicate someone else's work. Can you review it if you can't replicate it? Probably not, or at least not particularly well. Then, you need to schedule things. You might want to retrain a model every day, or send this mail with the latest KPIs you've calculated, to update a table in your data warehouse so someone else can use it in their work. It's tempting to think that scheduling is easy. You use cron, you say which time each day you wanted to run it, and that's it. But actually, it's a real pain to do scheduling right. First, your job needs to run somewhere. Wherever it runs, the environment it runs in needs to match the environment you use when you're writing it and testing it. Then, it needs to get triggered somehow. And this is where cron comes in. But triggering it at the same time every day doesn't work. You might be waiting for a certain data set to become available or to be updated. You might be waiting for someone else's job to finish first. Your job might have multiple upstream dependencies. I need this table and this other model to have been built first before I can run my job. Doesn't matter how you schedule that. It's going to go wrong sometimes because other jobs can get delayed. And that's not even considering rerunning your job if something it depends on produce the wrong output. What happens if you don't take account of these things? At some point, what will happen is you'll send a mail like this to your C-level execs. In case you're wondering, I have absolutely done this or something similar in the past, and not just once. It doesn't feel good, and it's surprisingly hard to avoid unless you think quite hard about scheduling. Then there's the question of how do business users consume your analysis? If you're providing a written report, that's one thing. But often you want to give them a tool to answer a bunch of their questions at once. You're building a custom dashboard for a particular domain. And there's lots of great tech in this space. If you're an R user, Shiny has been fantastic for a long time. Recently, dashboards in Python, frameworks like Voila or Streamlit, have come an awfully long way and are actually pretty good. They do, however, have some of the same problems as we just talked about with scheduling. These things need to run somewhere. It needs hosting. The environment that it's hosted in needs to match the environment you use to write it. And the conclusion of this is all, we've seen these two complications. If you want to work on your laptop, you need to maintain your own development environment. Maybe you're running Jupyter Lab locally. Maybe you're running RStudio locally. That's fine. But there is an environment behind it. It's all the libraries you've got installed, the version of Python, maybe even the operating system that's on your laptop. If you want to run your code elsewhere for code review, or as a scheduled job, or as a dashboard, you need to know how to replicate that environment somewhere else. And that's not trivial to do. The goal of a data science platform is to make these things easy, and in particular to make them easy for the data scientists who have to do them. And that brings me to the core of this talk. If you're thinking about building or buying or renting a data science platform, what do you need to consider? And I'd like to address this by taking you through the 4 ages of data science platforms at King, from back in 2014 right through to the present day. And I'd like to use that as a framework to discuss what you might want from such a platform by telling you what's gone wrong and I guess right with each of the things we tried. When I say we in this presentation, I largely don't mean me. I mean all the people who've worked in the data science technology team at King building this stuff over the years. I am omitting some details and complications at every stage, but as a summary, I think this presentation is pretty accurate. I'm dividing platforms at King into ages, but of course, there's no instant transition between them. And in many cases, technology from the previous age hung around for a long time afterwards. So, I said 4 ages. Let's get going. And I'm calling this one the first age because it's my presentation, and I get to decide the names. But really, it's just the situation in 2014 when I joined King. Had a look at the numbers. Back then, about 20% of data scientists at King had a CS background. So a little more than double what we have now. And in 2014, we ran pretty much everything for data science on one reasonably big server. You'd SSH into it, run some Hive queries, pull the results back down to your laptop probably, maybe do some analysis in R. If you wanted, you could try and install the Hive client on your laptop. It almost certainly wouldn't work. On the server, you could schedule things. You could schedule things using cron. And you could deploy dashboards by running whatever you wanted to on the machine, assuming you could find a port for your server that someone else wasn't using, because, of course, everyone was doing the same thing. If you asked really nicely, someone will give you sudo on the machine. And this was good and bad. It made your life easier. It might make everyone else's life harder. And the reason for that is it's a shared environment. If I needed a different version of dplyr, and this was a version that contained breaking changes, and I was just like, fine, I'm going to upgrade dplyr because this is what I want, I might have just broken the schedule jobs of, say, 20 other people. And I won't know about it. Or at least I won't know about it until the why is my job broken now, it worked fine yesterday mails start making their way around the team. So that was one thing. A bigger problem turned out to be the tragedy of the commons. A single big server is a shared resource. So if you used up too much CPU, memory, disk space, it would impact everyone else who was trying to use that machine. As it turned out, disk space was the biggest problem for us. We'd run out of disk space, nothing worked. You might say, why not just buy a bigger hard drive? We had a lot of data. People would pull a lot of data down from Hadoop. I think we had Europe's biggest Hadoop cluster at that point. You couldn't just buy your way out of this one in that way. At the time, we dealt with it by sending out a mail when the disk was full, naming the biggest offenders. Internally, I refer to these as the shame emails. It would be everyone's home directory, how much space you're using. Hopefully, at least one or more of those people would see this email and be like, ooh, that's me. And they would delete some things, and then all of a sudden everything would work again on the server until the next time it ran out of space. It's fair to say that this was not a great way of doing things, and I do not miss the shame emails. Of course, the only thing better than one big server is 2 big servers. We tried this one too. It's the same problems. It doesn't really help. So my takeaway from the one server to rule them all age is that sharing resources between data scientists is probably a bad idea. Sure, potentially having access to lots of CPU, RAM, and disk space to do your work is great. But if everyone wants those things at once, and of course everyone's working similar hours, so they might do, then no one is going to have a fun time at all. So that's the first stage. Server everyone shares, you log in and run stuff on it. Do any of you still work like this? Do you have one server for your team and everyone does stuff on it? Oh, it's great if you've got better platforms than that. Obviously, 2014 was a long time ago. So this persisted for a while. Artisans thought we tried something else, and I'm going to badge this as the second age. So if the problems in the first age were largely caused by shared resources, well, an easy way of solving that is don't make anyone share. How do you do that? Well, you give everyone their own virtual machine. And we did that. I was looking back at it, I was like, really? At this point, we were slightly smaller. We had only maybe 80 data scientists. We had 74 virtual machines. Technically, they were assigned to teams, but what actually happened is you edited a wiki page and put your name on a machine. You're like, this one is mine. Don't log into it. And this was this was interesting. It was your own Linux machine to do with as you like. It didn't have an enormous amount of CPU or memory, but it was exclusively for you. The arrangement we had is if you broke your machine, we wouldn't fix it for you. We didn't want to get involved with that, but we would, however, reset it to scratch, and then you could work on it again. So you could use any environment you liked, install whatever you want on it, schedule your own jobs, still via cron. You could deploy your own dashboards, And the way I think about this is some people really like DIY. And some people just want a chest of drawers to put their clothes in. And if you wanted to be a sysadmin, this was your chance. You had your own server. You could run whatever you wanted on it. You could learn and use Docker. Or you could manage your own dependency issues however you wanted. You could update packages, watch it break other things, knock yourself out solving that sort of problem. And there are many amazing opportunities for learning through this. But I mean, from our side, mostly what we learned from this is that if the new way of doing things is hard, people will continue doing things the old way for as long as they possibly can. So when we launched these VMs, they were very, very useful for a very small number of people. And most people didn't move off the one server. Most of those VMs sat unused. Occasionally, teams would absorb other teams' VMs. I actually managed to log into some of them the other night. They're still around. Going back to my point about how these ages aren't delineated that clearly. But as an example, we told people, hey, look, you can deploy your own shiny dashboards on these things. And people said, well, that's great. And then we said, well, actually, if you're going to do it properly, you should Dockerize them and then deploy it on your VM. We wrote a nice guide to that, which we thought was very clear. We checked back a year later. We had exactly 2 shiny dashboards deployed that way. Turns out our easy was not everyone else's easy. So that was the VMs for everyone age. Everyone could have their own machine if they wanted. And it turned out that some people liked that, and an awful lot of people had no interest in it. And you can see that if your background is economics, you're used to writing R scripts. Do you want to be a sysadmin? Do you think being a sysadmin is core to your job? Is it a set of skills that you really want to learn? Probably not. Quick show of hands here. Does anyone here have run on the basis where you have a machine per person? And I don't mean your laptop for doing data science work. No? I mean, that seems sensible. So what was good about this age is we did solve the problem of shared resources. No one had to share. But it was hard enough to use that just no one wanted to use it. onto the third age. And this is where things start getting really interesting from a technical perspective for us. And we tried again with big servers. And you might be thinking, well, you already told me you did that. What's different about this one? There were two things. First is we had a server per office location. So we have major offices in London, Barcelona, Stockholm. We have more offices these days than that. But we had one per location, and we managed to control the environment. We use Docker. And the important part here is we use Docker. The data science didn't have to. Each server would run the same Jupyter Hub image. You could log into it without having to worry about all that sort of stuff. And the image already had the things we thought were important installed in it. It would have the libraries we thought were worth having. It would have the versions of R and Python that we were willing to support, all that kind of stuff. If you wanted something else that wasn't that, you could maybe install it yourself, although it probably wouldn't be available to anyone else, or you could go back to your DSVM. The big win on this one is all of a sudden we could solve scheduling or solve a particular part of scheduling. Since everything runs on top of Docker and on top of a Docker image, you've got a consistent base, which means your jobs no longer have to run on the server they were written on. We could just clone your code from Git, mount it into an image running somewhere else, and run it. By this point, another team at King had built a nice dependency-based scheduler that we thought was friendly enough for data scientists to use. So we integrated with that, and we banished cron-type solutions for good. No one is using cron anymore at King. You can run your job when the data you need is ready, and you can run it in a consistent environment that isn't suddenly going to break under you because someone else changed something. Of course, it's not like the commons problems we had before when we tried big servers went away. But it turns out the key difference was this. If you have one server per major office location, then anyone who was competing for resources with you was probably within Nerf gun range. And you know, it turns out it's a lot easier for smaller groups to self-organize, to manage things like disk space, than for the whole company to do it via a mailing list. And we didn't have to send shame emails. Someone would come over and be like, hey, it looks like you've filled up the disk, could you delete something? All much more civilized. We still didn't have a great solution for deploying dashboards in this version. They probably still happened on the virtual machines. But the big win in this age was definitely environment and scheduling. And our takeaway from this is, yes, having a managed environment requires someone to put some effort in. Someone has to maintain your Docker stack of images. Someone has to make decisions about what are the versions of packages we're going to have installed, how are they going to play nicely with each other. So for my team, this was quite a lot of maintenance effort, keeping the images up to date, installing new packages when people requested them. But from a data scientist's perspective, they didn't have to do anything. And you know, if my team is 4 people and the rest of the company is 90 data scientists, say, this is a big win for overall efficiency. And we ran variants of this architecture for about 3 years. This was pretty successful. And you know, it might it sound like we just went back to the first age, but really, and in fairness to us, you know, Docker as a company only formed in 2013. Back when we were doing this the first time round, Docker really wasn't a thing. So I don't feel so bad about our first attempt at this. In this one, you might still be in competition for resources, but you're in competition locally. And you could come to a sensible agreement about, hey, look, I'll pause my job, you can run your job, when it's done, that kind of thing. And that brings us through to where we're at now, which is quite different. From the previous ages, we discovered a number of things we wanted and some things we didn't want. We wanted everyone to have their own resources. That's what we learned from the periods of shared servers. We had some workarounds for it, but still, it would be nice if we didn't have to do that. We wanted a managed environment so that jobs could run anywhere, or jobs could be scheduled anywhere. They didn't have to run on exactly the machine that they were written on. From my team's perspective, we didn't want to have to maintain Docker images. We had a whole stack with various levels that built on top of each other that we would update. You know, we did it. It was quite tedious. It didn't feel like a good way of doing things. in terms of the company, the biggest thing that had changed from the city-states age was that in early 2018, we'd begun transitioning King's data architecture to Google's cloud platform. As I said, we went from having Europe's biggest Hadoop cluster to being one of the largest single customers on BigQuery. Being on GCP also meant we had access to the other Google Cloud products. So things like Firestore, App Engine, Compute Engine, and most importantly for us, Google Kubernetes Engine. And we'd done some trials with this before. We had a period where we ran scheduled jobs via Compute Engine. We'd spin up a dedicated machine to run each job. But in late 2019, we hard committed on running Jupyter in a Kubernetes cluster, largely along the lines of this super handy guide, which was saved us a lot of time on setup. And in fact, I checked this guide the other night. It's still being updated for recent versions of Kubernetes and Helm and so on. The other thing we did was switch Docker image. Rather than build it all ourselves from scratch and have to make all these decisions and maintenance things, we now base off one of the Jupyter Docker stack images, which comes with everything we need built in and some things we don't necessarily need but might be nice. For example, our notebook platform now supports Julia without us having to do anything. It's just another kernel installed. And then on top of that, we add some King-specific customizations. We have a lot of internal libraries, integrations, that kind of thing. But we just build on top of that. And I got to be honest, obviously I would say this, but it works really well. If you're a data scientist at King, you start your day, you go to dataland.ds.midasplay.com, you hit the sign-in button. It'll go through a Google authentication flow because all our stuff depends on GCP. If you want to query BigQuery, you need Google credentials, permissions, and then you'll get a screen like this. Pick what sort of machine you want. We're running on Kubernetes. It doesn't really matter to us. We could spin you up anything, but we decided people didn't want a list of 20 options to choose from. We ended up picking these. Most people are fine with standard, which is essentially a fairly powerful laptop. One of the oddities of King is although we deal with large data, our philosophy tends to be that if you're dealing with large data locally, you're probably doing it wrong. You should offload your computation to somewhere where there is more of it, such as BigQuery. If you actually want a large machine and you do have a reasonable use case for that, and things like machine learning jobs are sometimes just easier to run locally, then we have options. And these machines are large. I think the large option here is something like 40 cores, 256 gig RAM. The ML one is the same thing, but 2 GPUs. They do take a little bit longer to spin up because we keep some standard nodes on standby. And of course, there is a price difference. I would say these are not the actual prices, but these are indicative of the sort of price difference you're looking at. If you want a standard machine, it's $50 a day. If you want a big machine, it's $30. And we don't police this, but we assume that our data scientists are smart enough to pick the smallest machine that will work for their use case. If you think what you're doing absolutely requires this and it's worth the business cost of $30 a day, then fine, do it. The bit of this that took longest for us in the end was we spent 2 weeks discussing what we should call the options. And to this day, I'm still a little disappointed that my suggestion of like tall grande inventi for our 3 machine types was vetoed. I still hope that at some point in the future, my pull request will be accepted and will be Starbucks. You pick your machine type. It will go through a flow where it mounts your home directory as a persistent volume claim, and then you're in. I could demo this later. I really don't want to do it live in case I accidentally leak something. But it takes somewhere between 30 and 60 seconds to get going. And then you start a new notebook and work. It's Jupyter Lab with a bunch of nice integrations. This is, in fact, the notebook I used to prep some of the graphs in this deck. And you can see, actually, in the second cell here, I'm pulling a Google spreadsheet without needing to authenticate again. It's nice. It's a nice place to work. As a data scientist, when you're starting a new project, do you want to create your virtual environment, install all the packages you think you might need, like start up Jupyter Lab, create a Git, all this stuff, or do you want to log in on a web page that has all these things done for you? And then, of course, you can deploy dashboards from this, and scheduled jobs run exactly the same way. They run in the same cluster in exactly the same environment, and in fact, you can specify what CPU, memory, and disk your job needs, and we'll spin up a machine to match it. It's really easy. We think this works. So I said previously, in other ages, people didn't necessarily migrate. This chart is percentage of data scientists using our platform over monthly, weekly, weekday. We have some odd usage at weekends. I don't think data scientists should be working weekends, but it's in there. And you can see monthly we're around about or above 100%, and that's because a lot of people who technically aren't data scientists by title also think the platform is nice and worth using. And of course, this graph is generated from a notebook I run on Dataland. And in fact, it runs as a daily scheduled job. I have a notebook that gets scheduled. It pulls Kubernetes usage data from BigQuery, some pre-processing, produces a graph, emails it to me every day. So easy. Of course, nothing is actually free. And there are two areas where the system is not a utopia. First is everything costs money. Spinning up a machine costs money. So Dataland has an inbuilt cost. Running scheduled jobs requires spinning up another machine. That costs money too. How much money it costs depends on what kind of machine you want, how much you're using. And this is very different to the previous ages where you have an upfront cost for the machine and then usage is free. For King, it's been an easy decision. It doesn't cost that much. And we have about 100 data scientists currently. If we make all of them a little bit more efficient, it easily pays for itself. But if you're a smaller company or have a small number of data scientists, maybe your equation is different. And there's another cost too, which is that in every other age, you might be able to get away without a team managing your platform. Even in the city-states era, you might be able to get away with one benevolent overlord data scientist per location managing the server. You can't run a Kubernetes cluster like that because there's a lot of moving parts. We've got Jupyter, Kubernetes, Helm and Chart Museum for package management, then Terraform and Atlantis for cluster management, Nginx for ingress, Drone for CI/CD pipelines, Argo for scheduled jobs. I sent this text to someone, he sent me a message back. He's like, you've missed at least 3 logos off this diagram. I can't approve this. There's a lot in there. And you can't ask a data scientist to do something like build and maintain something like this in their spare time. Now that it's running, maintenance is fairly light, but it was a brutally steep learning curve over the last year or so. So that's pretty much where this history finishes. We moved from one big server to a small virtual machine per person, to a big server per location, to a Kubernetes cluster that spins up a machine per person. Along the way, we've come out with some ideas about what makes a good platform for data scientists. Things like don't make people share. Ease of use is a feature, and a managed environment is worth the effort. You might be thinking, so what? We built our own platform. Am I saying that you guys should all do the same? Well, no, or at least not necessarily. The points I hope I managed to make are that first, having a platform for data scientists to work on might be a good idea if you don't have one already. Second, that there are a lot of possible options. Aside from the 4 ages I talked about today, there are a whole bunch of commercial data science platforms that do many of the same things we've done internally with Dataland. And the way I would think about this is the same way I think about any data science project. How much is this going to cost us in terms of both time and money versus how much data scientist time and frustration and hence value is it going to gain us? And if I think that equation is strongly in one direction, then maybe this is worth doing. And that's everything I wanted to cover. So thank you for your attention.